So let's look at number 7103. I have a unit circle drawn below, and I'm going to label a point that corresponds to each rotation of pi over 6 radians. And I'm doing this below the problem because I don't have as much room otherwise. Pi over 6 radians would be maybe right about here. So this point, let me do this in red here, would be pi over 6 radians. We could do the other points here. That's not a very straight line, was it? Let me try that again. And I'll put in the rest of the x-axis here just so we have it. And you end up with a picture that looks something like that. So this is our 4 angles that are pi over 6 radians away from the x-axis. What are the coordinates of this point? So at pi over 6, remember the coordinates, the ordered pair at any point on the unit circle is going to be the cosine of theta, sine of theta. So what I have to know is what is the cosine of theta? What is this length? Remembering that this is our pi over 6. So the length is radical 3 over 2. And this goes back to our 30, 60, 90 triangles. Because remember, this is 1. Pi over 6 is the same thing as saying 30 degrees. So if the hypotenuse is 1, we know 2 things. We know that the side across from 30 is going to be a half. So that tells us our sine. And we know that the adjacent side is going to be radical 3 times the shorter leg. So I'm able to figure out my coordinates there. Now, just because this next problem uses a couple of these angles, I'm not going to redraw them. But let's go ahead and talk about what we've got here. So I have hypotenuse of 1, okay? Now, if each of these rotations is pi over 6 away from the x-axis, what I end up with is in the second quadrant, I'm going to end up with 5 pi over 6. And we kind of talked about how we got that on the unit circle. Here, that's going to be 7 pi over 6. And then here, this angle would be 11 pi over 6. Okay, so I've got, and I'm going to actually write those out on the outside of the circle. Okay, so this angle right here is 5 pi over 6. If we rotate from 0 to there, this angle is 7 pi over 6, and this angle is 11 pi over 6. Now, what that tells us is that the length is going to be the same on all of these. So my x-coordinate will be very similar to what I've already written. Let me get my ordered pairs ready here. My x-coordinate is going to be either radical 3 over 2 or negative radical 3 over 2, depending on which quadrant I'm in. So if I'm in the first and fourth quadrants, I'm moving to the right. That means it's positive radical 3 over 2. In the second and fourth quadrant, or second and third quadrants, I move to the left, so it's negative radical 3 over 2. Okay, and then my y-coordinate, again, will be the same, just depending on whether I'm above or below the x-axis. So when I'm above the x-axis, it's 1/2. When I'm below the x-axis, it's going to be negative 1/2. Now, why did I just do all of that? Well, because in the problem to the left here, it wants me to figure out what the tangent of 7 pi over 6 is. So I can do that by looking at the unit circle. So the tangent of 7 pi over 6, well, that's going to be the sine of 7 pi over 6 over the cosine of 7 pi over 6. All right, so I'm going to try and keep this color coded for you, so let me fix this here. So the tangent of 7 pi over 6 is going to be the sine of 7 pi over 6 over the cosine of 7 pi over 6. All right, now the sine of 7 pi over 6, we can look at the unit circle, and the sine corresponds to the height, or the y-coordinate. We have that written here as well. So that's 1/2. So the sine of 7 pi over 6 is 1/2 over the cosine of 7 pi over 6, which is going to be the x-coordinate. Cosine represents the x-coordinate, and I'm using not 7 pi over 6. That should be negative 1/2. Sorry about that. 7 pi over 6 is down here. So negative 1/2, and then negative radical 3 over 2. And then we go through that same process that I talked about in the previous video to simplify this, and we're going to end up with just positive radical 3 over 3. So the tangent of 7 pi over 6 is positive radical 3 over 3. Now, 2 asks you to find the cosine of 13 pi over 6. Now, what's interesting about this is that 13 pi over 6 is not on my unit circle anywhere. But look, I know that this would be 2 pi if I went all the way around the unit circle, right? 2 pi, if I wanted to write that with a denominator of 6, I could multiply top and bottom by 6. And I get 12 pi over 6 is 1 rotation. So if I wanted 13 pi over 6, I'm going to go all the way around once, and that's 12 pi over 6. Now I need 1 more pi over 6. So this is really the same thing as the cosine of pi over 6. All right, and then in that case, I just need to look at the x-coordinate, the cosine, at pi over 6, and that's just radical 3 over 2. Okay, and then 2 pi over 3. So I'm going to have you guys try that one. I'll put the answer here, but pause the video for a second. Try it if you haven't already done so. Hopefully this all helped, this explanation. Try looking at your unit circle or drawing it on this unit circle and seeing if you can find the tangent of 2 pi over 3. So I've got some work up there for you if you want to check it. Remembering that the sine of 2 pi over 3 over the cosine of 2 pi over 3 is going to give you the tangent of 2 pi over 3. And then to figure out your sine and cosine, you just need to look at the x and y coordinates at 2 pi over 3. And it should reduce just to be negative radical 3.